Lesson 5.5, a lot of special right triangle work in here. All right, so on this figure, which I'll blow up a little bit, it tells us that CA is 6. Red, 6. It tells us that angle CDA is 30, so that's a 30 over there. And it tells us that CAD is a 90, so that means CAB is a 90, and CBD is 51. And be careful that you don't look at this as an altitude drawn to a hypotenuse, because this angle up here at vertex C is actually 99 degrees, because that's a 60 because of the 30, 60, 90 for CAD, and then 51 would be 51, 39. So those are the measurements there. Now, if we want to find, number 3, find BC, then I'm going to do a trigonometric function here. I'm going to say that the sine of 51 degrees is the opposite, which is 6, over the hypotenuse, which is BC, which is the segment that we're after. That means BC is 6 divided by the sine of 51. And you put that through your calculator and round it off, it'll be 7.72 feet. All right, oops, actually, let's put that in the wrong place. So let me move that down into right there. And then also bring the letter S down here. All right, now to find BA, BA is going to be what? Let's do the tangent of 51 is the opposite 6 over the adjacent BA, which means BA is 6 divided by the tangent of 51. If you put that into your calculator, you'll get, round it off, you'll get 4.6886 feet. All right, CD. Now, CD is a little bit easier to deal with, because if I pull triangle CAD out like this, right angle here, CAD, and that's a 30 and that's a 60, then I have a special right triangle, and the 6 over here is the short side, which means the hypotenuse must be twice as big and be 12. That's why CD is equal to 12. And then AD is the long side, which is the short side, CA, multiplied by root 3. And I guess they want that rounded off, so that would be 10.39 if you put that through your calculator. These are all feet, by the way. Make sure you get your label. And then BD is going to be the sum of BA and AD. We got BA and AD in problems 4 and 5. We just add those together. Then BD, which is, where are we, number 7, they're going to be approximately 15.25 feet when we add those together. Now, the area, which is number 8, is 1/2 the base, which is BD, which we just found out was 15.25 approximately, times the height, which is CA, which is 6. And if you multiply that through, we get 45.75 feet. So recall, and I'll draw this in an orientation a little bit different than the problem, but if you have a 30, 60, 90 right triangle, 30 here, 60 there, and the short side is labeled X, then the hypotenuse is twice that value, and the longer leg is the short leg multiplied by root 3. Okay. We'll use that coming up here. All right, so in the set section, this is a 45, 45, 90. How do I know that? Because it's isosceles. Two sides equal mean the opposite angles have to be equal. Only 90 degrees left. So this side has to be a 6. And then the hypotenuse of the 45, 45, 90 is the leg multiplied by root 2. So we call that, we discovered that by putting an x and an x here, putting an h for hypotenuse, and doing x squared plus x squared equals h squared, and solving for x, it came out that, solving rather for h, solving for h, it came out that h was x root 2. All right, 30, 60, 90, which is number 10. We have the hypotenuse. The short leg is half of that, so that's 4. This is feet. I'll make sure I get my labels, inches here. And then the long leg of a 30, 60, 90 is the short leg, which is 4 multiplied by root 3, so that's 4 root 3. Number 11, we've got the short leg of the 30, 60, 90, so the hypotenuse must be twice that, 26 centimeters. And the long leg is the short leg multiplied by root 3, so that's 13 root 3 centimeters. All right, what do we got here? 11. Okay, 12, sorry. This is 30 degrees here, so I have the hypotenuse of a 30, 60, 90. So the short leg must be half of that. This must be 11 centimeters. And then the long side, the long leg, I should say, is 11 root 3 centimeters. Back to a 45, 45, 90 on number 13. So the other leg is congruent, so it's 1 centimeter. This will be root 2 centimeters. 1 times root 2 is root 2. And last but not least, we have the 45, 45, 90. So the way I think of this is what the relationship between the hypotenuse and the leg is root 2. You multiply by root 2 when you get from the leg to the hypotenuse. So I'm going to divide by root 2 to get back. If I rationalize the denominator by multiplying by root 2, multiplying by root 2 over root 2, I'll get 12 root 2 over 2, which is 6 root 2. And that'll be centimeters. And this is congruent to that, so it's 6 root 2 centimeters. Okay, what do we got next? Okay, so using the triangles above, so if I have say a 45, 45 with a 1, 1, root 2, then my sine is going to be 1 over root 2, because the sine of 45 is the opposite of the hypotenuse. If you rationalize that, you get root 2 over root 2. The cosine is going to be the same, because the opposite and the adjacent are both 1. So that's going to also be root 2 over 2. And the tangent of 45 is going to be opposite over adjacent. That's going to be 1. All right, if I go with 30, 60, 90, and I put a 1, a 2, and a root 3, 30, 60, 90. So remember the relationship between the short leg and the hypotenuse is the ratio of 2, 1 to 2, or 2 to 1. And the other way, the long leg to the short leg, the ratio is root 3, either root 3 to 1 or 1 to root 3. So the sine of 30 degrees is going to be the opposite 1 over the hypotenuse 2. The cosine of 30 degrees is going to be the adjacent root 3 over the hypotenuse 2. And the tangent of 30 degrees is going to be the opposite 1 over the adjacent root 3. If I rationalize, I get root 3 over 3. If I switch to the 60 degree angle, the sine is the opposite over the hypotenuse. So that's going to be root 3 over 2. The cosine is going to be the adjacent over the hypotenuse. So that's going to be 1 over 2. And the tangent of 60 degrees is going to be root 3 over 1, which is root 3. Best to get those memorized. All right, the go section here. Identify the type of function, linear, quadratic, or exponential, represented by the graph. Write the explicit equation. So as I look at this, my x's are going sequentially with the counting numbers are natural, 0, 1, 2, 3, 4, 5. And I notice that the y values are doubling every single time. So that's forming a geometric sequence, which means it's an exponential function. The first term of the first value is 3, so it's going to be y equals 3. The multiplier is 2, so it'll be y equals 3 times 2 to the x power. Very nice. On the next one, I notice there's a symmetry about the point 2, 0. I have 2 2's here. I have 2 8's over here. I don't see 2 18's, but if I looked a little further, I would see it. So that means the vertex, this is, first of all, it's quadratic. Another way to tell a quadratic is that well, I don't know if this is actually introduced, but the first differences are 2, 6, and 10. And the second differences are all 4's. So the first difference is 0 to 2 is 2, 2 to 8 is 6, 8 to 18 is 10. Let's go with first differences. Notice the differences here are 4. That actually suggests that the a and the ax squared plus bx plus c is 2. It's half of that value. The vertex, though, is 2, 0. So I'm going to say y equals x minus 2 squared plus 0. That's my vertex form. And my second differences went to 4, so my a value is 2. All right, so this one we're getting from the graph. I can tell by looking right here that the vertex is what? -3, comma, -2, right? So I know I'm going to have y equals x plus 3 squared minus a 2. And then if I go increment by 1, I notice the graph goes up 2, so that means there's a 2 right here. Somewhat like the previous one. So the function is quadratic, and the equation is what I just typed in up there. So this one, the type of function was quadratic as well. And the equation is right there. And the first one, this is a little non-sequential in terms of the pagination, but this is exponential. And the equation is right there. What do we got next? Okay, so this, you should clearly on this one be exponential, right? We're seeing this asymptotic behavior. And I notice that at 0, I've got 8. So that means my first value is 8. That's kind of my y-intercept. And then if I look at 2, I'm all the way down to 2. If I look at 1, I'm at 4. So I'm going 8, 0 is 8, 1 is 4. I'm observing this in the graph. 2 is giving me 2. And 3 is giving me 1. Notice that's putting half each time. This is geometric progression. A geometric progression, my r value is equal to 1/2. So this will be 1/2 of the x power. So we're exponential. Pardon my writing. This is from the 1950s. Penmanship. And there's my equation up there. And I believe that's it. 5.5 in the books.